Baseball, baseball, boop, 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 boop. Okay, so what we're looking at here is another vertical motion problem for Unit 3, one of the C2 problems, number 3 here. And what we have is we've got a baseball player, and to celebrate a victory, a pitcher is throwing her glove straight upward with an initial speed of 6 meters per second. So let's just do to ourselves a little picture here. Here's a person. Yeah, their arms aren't attached, but that's okay. And here's their glove. And they're throwing that glove straight upwards in the air. Now, there's two parts to this question, A and B. In part A, we're asked, how long does it take for the glove to return to the pitcher? So how long does it take for the glove to go up, hit some max height, and then come back down? In part B, it's just asking, how long does it take for the glove to get to this maximum height? So we can actually do part A or part B first. It doesn't actually matter. In either case, there are some things that we can think about in this problem that are going to really help us out so we can tackle it any order we want. What we know initially, though, is that she's throwing this glove up with an initial speed, a VI, of positive 6 meters per second, because we're going to call upwards the positive direction here, okay? And that means down the negative direction. We also know a few other things. We know for both problems, A and B, we know acceleration is due to gravity. That's the negative 9.8 meters per second squared. Negative because we called down the negative direction, and gravity is acting down, okay? And there are a few other things we know here. If we were just looking at part A, coming back to this initial position down here, we know the following. If you throw the glove up and the glove comes back down and you catch it again, it's returned to its initial position. So we could actually say that the displacement here is 0. That would give us 3 things, and we can start solving this problem. We actually know a little bit more information than that, though. We actually know that when this glove returns back down, whatever velocity we threw it up at, it's going to return with that same velocity at every point on the way back down here. So she threw it up from her hand at 6 meters per second. When it comes back down, it's going to have the same speed, 6 meters per second, but just in the negative direction. So that actually means we know here that the final velocity at this return point is negative 6 meters per second. So there's a lot of different things that we could do here in order to figure out what's going on. So we know 4 of the 5 things. So we could actually use, for question A, we could use equations number 3 or equation 5 to do this. Equation 4 looks like you can use it, but if you take the final velocity plus the initial velocity, you just get 0, and it just shows you that the delta x is 0. So not super helpful there. If you wanted to, though, you could also look at part B first. You know that whenever this glove gets to its maximum height, you know that if we stopped the problem right there, its final velocity would be 0, because we know that a velocity is 0 at a maximum height. This would give you 3 things. It'd give you an initial velocity, a final velocity, and an acceleration, okay? So this time we have 3 things. And in this case, we could just use equation number 3 to solve that out. Let's just use part A first. Let's just do part A, and then we'll work our way into number 3. We'll see why it doesn't really matter in half a second. For part A, we're going to use the VI of positive 6, the VF of negative 6, and acceleration here, and we're going to find a time. We can use equation number 3, like I said, to do this. It's just going to be VF equals VI plus acceleration multiplied by time. To do this, I need to subtract the VI over first. So we're going to have VF minus VI equals AT. And then now to get that time by itself, I'm going to divide each side by the acceleration. Careful, because that numerator is in parentheses. And this allows us to find time. If we throw in some values here, we're going to have the final velocity was negative 6 minus the initial velocity of positive 6, so negative 6 minus 6, over negative 9.8. This will give us, come on, move for me. This is going to give us negative 12 over negative 9.8, and that will come out to be a positive, which is nice for a time, 1.2 seconds, okay? That's how long it takes for the glove to go up and come all the way back down. Now, if you're just asking how long does it take just to go up then, Well, it's half the time. You went halfway, and acceleration due to gravity was causing everything. So it is literally just you take half of that time. So half of 1.2 is 0.6, and that's the answer for B. This is why I said we could do B first. If we solved for B, we would get 0.6, and then we could just say double the time to get back to A. So it doesn't really matter which approach you take there. Both will work. If you wanted to work out the maths all the way, you could, but there was no need to because we know these kind of little tricks to get us through physics problems. So that was it. So not too bad of a problem there. Just recognizing what we had, drawing a little picture here, identifying an equation, and then working through the math. So with that, this problem is finished. Adios. Take it easy.